So we are going to look at what is a function in Python, then we'll see the different types of Python functions. Then you will understand the various advantages of using Python functions, and finally we'll head out to our Jupyter notebook to understand Python functions in detail with hands-on demonstrations. Okay, so what is a function in Python? So a function is a bunch of statements that are defined to perform specific operations. A function in Python helps to divide your program into smaller and modular chunks, thus allowing you to make extensive programs more organized and manageable. It also avoids repetition and makes the code reusable. So let's understand the types of Python functions. First we have built-in functions. So these are the functions that are built into Python. So by default, the inbuilt functions are available in Python. Then we have user-defined functions. So functions defined by users to carry out certain tasks are called user-defined functions. They don't have a fixed name. So here on this slide you can see the different built-in Python functions that are available. So you have power, length, next, max, absolute, we have print, range, slice, sorted, round, and there are many more. So these we will explore in our demo session. So wait for a while. Now let's understand about the user-defined functions. So these functions are defined by users to perform specific tasks, and these are the steps that you need to create a user-defined function. So first you need to create the function and then call the function. Now moving to the next slide. So here you can see the syntax of writing a user-defined function. So we use the def keyword to define the function, followed by the function name, and within brackets you have the parameters or the arguments of the function. Then you have the function block, and if you want to return a value from the function, you can use the return function followed by the expression. So here is an example where we are just printing hello Python using a user-defined function, and in this case my function name is called my underscore function. Now if I call my underscore function, it will return me hello Python. Cool. Okay, now let's understand the advantages of using Python functions. So with the help of functions, you can avoid rewriting the same logic or code again and again in a program. So in Python, you can call functions anywhere multiple times in a single program. You can also track an extensive Python program easily when it is divided into multiple functions. And the most crucial feature or the advantages of Python functions is that of its reusability. Cool. Now let's head over to our Jupyter notebook and we'll explore the inbuilt and user-defined functions in detail. Okay, so I'm on my Jupyter notebook. First I'll go ahead and rename my notebook as functions in Python. I'll click on rename. Okay. First of all, let me just increase the size. Okay. I'll give my comment as built-in functions. Okay. So we'll start by looking at the absolute function in Python. So absolute or ABS function returns the absolute value of a number. So I'll say, let's say a equal to, I'll use the absolute function which is represented as ABS in Python. Suppose I write ABS of, let's say 10.75, and if I print a, it gives me 10.75, which is fair enough. Let me just copy this code. I'll paste it here. I'll say b equal to ABS. This time I'm going to use the negative symbol or the negative sign. I'll say minus 10.75 and we'll print b. Let me run it. You can see here Python has automatically removed the negative sign and it has just given us 10.75. So this is how the absolute function works. So ABS returns the absolute value of a number, which is always positive. Now let's see another inbuilt function, very popular, which is called the length function or len. I just give a comment saying len. Above also let me just give a comment as ABS. Okay. So later we can have a track of whatever functions we have learned in the demo. So the length function returns the length of an object. It could be an iterable such as a list, it could be a tuple or even a dictionary. Let me show you how it works. I'll say list1 equal to, I'll create a list within square brackets. Let's say I have a few letters, let's say I, N, then I have D, I again, and A. So I have all the letters in my word India. Now if I say X equal to len of list 1, then I'll print X. It gives me 5 because the length of all the characters in my list is 5. You can count here INDIA. So there are only 5 elements and hence it is written as 5. Now we'll explore another function which is called as all. So the all function returns true if any item in an iterable object is true. So I'll say my underscore list equal to, let's say I have 0, 1 and 0. I'll say X equal to, then I'll use the all function, and inside the function I'll pass in my list which is my underscore list, and will print X. Hold on for a second and can you please guess what this X will be? It gives us false. The reason being we have two false values 0 and 0 here, and there is only one true value which is 1. Suppose I had 1, 1 and 1. If I run this, it would have given us true because all the elements in my list or the iterable are true. If any one of the elements is false, it will give us false. Okay. Now moving to our next function, which is called sum. So Python sum function is used to get the sum of numbers of an iterable. Let's say I have s equal to, I'm using the function sum, and inside the sum function I'm going to declare a list of numbers. Let's say we have 20, 35 and let's say 70. Let me create another list called s1. I'll say sum, and now let's say we'll pass in a tuple now, so I'm using another bracket. We have, let's say, 7, 5 and 9. Now if I write print s, and let's say I want to print s1, you can see here my sum function has returned the sum of all the numbers in the iterable. The first one was a list, and next we have a tuple. So 20 plus 35 plus 70 is 125, and then 7 plus 5 plus 9 is 21. So this is how the sum function works. Now moving ahead, we have the max function next, as well as the min function. So as the name suggests, the max function will return the maximum number of an iterable. So I'll create a variable called m1 and I'll use the max function. Let's say we have a few values 7, 10, 3, 12, 61 and 40. Now let's go ahead and print m1. Now if I run it, it returns me the maximum number that is present inside my list of numbers or the tuple that I have passed in. Here you have the maximum number as 61. Now let's use the max function over a dictionary. So I'll create another variable called m2 and I'll say max, and inside the max function I'm going to pass in my values in the form of a dictionary. So I'm using curly brackets or braces. I'll say, let's say 7, 90, we have 3, let's say 150, 67 and 44. Now let me go ahead and print m2. If I run it, you can see it here, it has given us 50, which is the highest element in my dictionary. Okay. Now similarly you can use the min function. Let me just copy this and I'll paste it here. I'll say m3. Instead of max function we are going to use the min function. So the min function will return the minimum number in an iterable. Let's say I'll pass in m3 as a list this time, and if I say print m3, it gives me 3, which is the lowest number or the lowest value in my list. And similarly you can have the lowest value printed from a dictionary, I'll just change the variable to m4, and instead of max we'll use the min function, and here also I'll use the variable as m4. If I run it, you can see here we have printed the minimum value in my dictionary, which is 3. Okay, now moving ahead, we'll explore another function called iter. So Python iter function returns an iterator for the given object. So the iter function creates an object which can be iterated one element at a time, and the next function returns the next item in an iterator. Let's use both iter and next function in our next example. So I'll create a list called myList, and I'll say equal to, followed by using the iter function, and inside the iter function I'm going to pass in a list which will have letters of India. I have N, D, I, and then I have A. Now I'll create another variable called X, and then I'll pass in the next function, and inside the next function I'll pass in my list, and we'll go ahead and print X. So it will print the first element in my iterable, that is I here. Now if I copy this and I'll paste it here, if I run it again, you can see it here, the iter function returns the second iterable, which is N in my list INDIA. I'll paste it again. If I run it, we have the third item in the list, which is D. Okay. Now coming to using the power function in Python. So Python POW, or the power function, returns the power of the given numbers. Let's say x raised to the power 3. So I'll declare a variable x1 and say POW. Let's say I want the value of 3 raised to the power 3, and let's say I have another variable called x2. I'll use the POW function, and this time I want to know what is 2 raised to power 4. We'll go ahead and print x1 and x2, and as you guessed it, 3 raised to the power 3 or 3 cube is 27, and 2 raised to the power 4 is 16. Cool. Now coming to using the range function. So the Python range function returns a sequence of numbers starting from 0 and increments by 1. So this is by default and stops before the given number. So let me show you. If I say x equal to, I'll use the range function, and inside the range function I'll have my value as 6. Then I'll say for n, now here n is my iterator variable, I'll say for n in x, print n. Let's run it and we'll see the result. You can see here the range function has returned us the number starting from 0, and it has gradually incremented the iterator by 1. So we have from 0 till 5. Now I'll show you another example. I want to change the default starting value, that is 0. So I'll say if x equal to range, I'm going to start from 40 till 50 with a step size of 2. So you can pass it as the third argument, so it will skip one value and print the next value. So then I'll say for n in x, I'll give a colon, let's print n, and we'll see the result. You can see here it starts with 40 and has a step size of 2. So we have 40, 42, 44, 46 and 48. Cool. Now let's move ahead and we'll explore the round function in Python. So the round function rounds off a number to the given number of digits. Let's say I have x equal to, I'll use the round function, and then I'll have a decimal value, let's say 8.62475, and I want to round it to 2 decimal places. Let's print x. If I run it, you can see here my Python has returned a rounded up value to 2 decimal places, so we have 8.62, and the rest it has just skipped. Now moving ahead, we'll explore the sorted function in Python. So the sorted function returns a sorted list of the specified iterable object. You can specify ascending or descending order. So I'll create a list called A, and we have the elements, let's say again India. So I have I, N, D, I, and I have A again. If I say x equal to sorted A, and if I print x, you can see it here, Python has sorted the elements in the list in ascending order of the letters. So we have A appearing first, then D, again I, and then finally we have N. Now suppose you wanted to print the letters in descending order, you can use another argument here. I'll give a comma and say reverse equal to true. So this line will ensure my list is sorted in descending order. You can see it here, it has just reversed the above result. So we have N appearing first, and I, D, and A. You can do the same for a list of numbers. Let's say we have 12, 50, 38, 76, let's say 27, 80, and 5. I'll say x equal to sorted A, and will print x. If I run it, you see it here, we have sorted the numbers in the list in ascending order now. If you want to sort it in descending order, just add reverse equal to true. There you go. Here my list has now been sorted in descending order of elements. Now we are going to look at the final built-in Python function, which is slice. So the slice function returns a portion of an iterable as an object of the slice class based on the specified range. Suppose I have a list called A. Okay, let's not define a list, we'll define a tuple. So this has the letters in the word Simplilearn. So I have S, I, M, P, L, I, again L, I have E, comma, I have A, then we have R, and finally I have N. So these are the letters which have been represented as a tuple. Simplilearn, then I'll use the slice function and I'll give my range as 5 and will print A of X. Let's run it. You see it here, the slice function has sliced the first 5 elements in my tuple. So we have S, I, M, P, and L. Cool. So we have explored all the important built-in Python functions. Now let's head over to using user-defined functions or learning user-defined functions in Python. I'll give a comment first, user-defined functions. Cool. So as we had learned in our slides, to define a user-defined function, we will use the def keyword and a function name. This should be a valid Python name. So I'm using func1 followed by parenthesis, and then we'll have a colon. And now we'll define the body of the function. I'll say print hello world. This is the same example that we had seen in our slide. Now I'm going to call the function using the function name, which is func1. If I run it, you can see it here, I have my message printed hello world. So this is a very simple user-defined function and it does not carry any arguments or parameters. Now let me show you another user defined function. I'll say def hello. Again, we are not giving any parameter to this function or arguments to this function. I'll say name equal to str. This time we are going to take the input from the user, so I'm using the input function. I'll say enter your country name. I'll give a colon and a space, and then we'll say print. I'll print the message hello followed by a space, give a plus sign, then we are going to convert our name to string. So this is my function. Let me run it. Now I'll call hello. It is asking me for entering country name. I'll say Japan. If I hit enter, it says hello, then my country name, which is Japan. So hello Japan. Let me run it again. This time I'll say USA. I'll hit enter. You can see here my message is hello USA. Cool. Now moving ahead to our next example, where we'll see using functions with different parameters. So we'll start with a very simple example. I'll say def I want to convert feet to centimeter. I'll say my function name as ft_2_cm. So I'll pass in a value for feet, and that feet will be converted to centimeters. And this time inside parenthesis I'm going to pass in my parameter as ft. I'll use the formula for centimeter. I'll say my variable centimeter equal to feet multiplied by 30.48. So 1 feet is actually 30.48 centimeters. So centimeter becomes feet into 30.48. Then we are going to use the return keyword, and I'm going to return the output, which is centimeter. Let's run it. Now to call the function, I'll use my function name, which is ft_2_cm. This is my function name. And then I'm going to pass in a value for feet. Let's say I want to convert 6 feet into centimeters. If I run it, there you go. You can see it here. 6 feet is actually 182.88 centimeters. Let's say 5.8. If I run it, it is 176.784 centimeters. So here you saw how to pass in arguments to a user defined function. Now again, you can pass in multiple arguments. Let's say I'm going to find the sum of two values. For that I'll create a function called def. My function name is add. I'm going to add two values x and y. So I'm passing in two parameters x, y. I'll create a variable called sum that will store the value of x plus y. And then let's print sum. Okay, let me just scroll down. I'll hit shift enter to run it. Okay, we have created my function, that is add. Now let's add 40 and 50. You have to pass in two arguments because we have declared x and y in the function, so it needs at least two arguments. If I run it, you have the sum of 40 and 50, which is 90. Let's say I have minus 20 and 30. If I run it, you have the result minus 20 plus 30 is 10. Alright. Now similarly, you can also multiply two numbers. Let me just copy this. I'll paste it here, and instead of add, I'll give my user defined function name as multiply. I'll say product equal to x asterisk y, and I'll print product. Let's run it. I'll call my function using the function name multiply. Let's say 4 multiplied by 6. So the result is 24. Cool. Now moving ahead, we'll explore another example. Let's say I want to print the absolute value of a number. So I'm creating a function called def. My function name is absolute, and I'll pass in one parameter which is x. I'm going to use a if-else statement. I'll say if x is greater than or equal to 0, I'll give a colon, then I'll say return x, else give a colon, I'll say return minus x. I'll run it. Now if I print absolute of, let's say, 56, the result is as expected. Since 56 is greater than 0, we have just returned 56. Let me just copy this. I'll paste it here. Let's say absolute of minus 56 is again 56 because we are returning minus x, so minus of minus 56 becomes plus 56. Now if you wanted to return minus 56, you need to make some modifications. I'll put another minus and keep this within brackets. Let me run the function again. And now if I print absolute of minus 56, you have the result as minus 56. Okay. Now let's see another example how to find the factorial of a number using a user-defined function. So we'll define our function as def. I'll use the function name as factorial. I'm going to pass in a parameter called x. I'll say if x is equal to 0, then we'll just return x or return 1. I'll say else, give a colon, return, I'll say x asterisk or multiplied by, I'll use the function name factorial, I'll say x minus 1. Now let's run it. I'll call my function factorial. Let's say I want to find the factorial of 5. The result is 120. Let's say the factorial of 10. The result is 36,28,800. Cool. Now let's see how you can pass in default arguments to your function or default parameters. Okay. Suppose I have a function defined called welcome. Here I'm going to pass my argument as name, and in the argument itself I'll pass in the value, a default value, let's say Paul, give a colon, and I'll print hello. This would be within quotes, and the name. Cool. Let me just run it. Now I'm going to call the function welcome. This time I'm not giving any value to my function. If I run it, it has automatically taken the default argument, which was Paul, so my message becomes hello Paul. Now let's say I'll pass in a value welcome, and within quotes I'll say Racy. Now the message becomes hello Racy. So if you pass in a value to your function welcome explicitly, it will take that value instead of the default argument. Cool. Now you can also have multiple arguments in your function, as we saw above for the addition and multiplication functions. I'll create a function called message, and we'll have the arguments as name1, name2, and name3. Give a colon. I'll say print a message that is hello. I'll give a space, give a comma. We have name1, give a comma, and then I'll say comma please tell, give another comma, I'll have my name 2, give a comma followed by the message that, then I have name 3, this should be a comma instead of a period, then I'll say is waiting. Make sure this is within quotations again, just give a exclamation mark. Okay, so I have my message, let's run it. Now I'll call my function message. We need 3 arguments now, so I'll pass in 3 names. Let's say my first name is Gilly, my second name is Rachel, and my third name is, let's say, Shaw. I'll run it, and you can see here we have my message printed hello followed by name 1, which is Gilly. So hello Gilly, please tell name 2, which is Rachel. So please tell Rachel that name 3, which is Shaw, that Shaw is waiting. Cool. Now we'll understand about scope of variables in a function. Now your scope could be a global scope or a local scope. Let's define a function called func3. Now inside the function I'm going to create a variable called z, which has a value of 7. Now I'll just print z and I'll call in my function 3. If I run it, you have the value printed of z, that is 7. Now if I want to access my variable, that is z, outside the function, if I run this, it throws me an error because this variable z was defined locally, that is inside the function, and you cannot access z outside the function. Now to overcome this issue, let me just copy this. We are going to declare z as a global variable. So I'll have z outside the function. I'll say z equal to 7, and then I have my function defined. I'll just change the name of the function to function 4, and then we'll print z, and I'll call the function 4. If I run it, you can see it here. I have the value of z printed, that is 7. Now if I want to access z outside the function, then also it's fine because we have defined z outside the function, that is z is now a global variable, so its scope is throughout the function. Now another thing to note here is you can't change the value from inside a local scope. So if I say z equal to 7, and then I'll define my function func, let's say 5, I'll give a colon, and I'll say, let's say I want to alter the value of z to, let's say, z plus 7. I'll print z, and let me now call func5. If I run this, it throws me an error. As I said, it says local variable z referenced before assignment. So you can't change its value from inside a local scope. For that, you're going to explicitly define the variable z as global. Let me show you how to do it. I've just copied this code. I'll paste it here. I'll say z equal to 7. I'll define my function, let's say func6. Here I'm going to say global z. So I've explicitly defined my z as a global variable. Now if I call the function 6, you can see here we have altered the value of z from 7 to z plus 1, that is 7 plus 1, which is 8. Okay. Now asterisk args in function definitions in Python are used to pass a variable number of arguments to a function. Suppose you don't know the exact number of arguments you need, so you can use the argument with an asterisk symbol. Let me show you how to do it. I'll say def welcome, and here I'm going to pass in asterisk followed by the name of my argument, which is names. I'll say print I'll print my message as hello, comma, then I'm going to say names, the first name which is with index value of 0, comma, followed by a space, then I have name 1, I'll give a comma followed by a space, and then we'll have names 2. This should be names. Okay, let me run this. Now I'll call my function welcome. Now you can see here I have passed in my argument, that is names, 3 times. So let's call 3 names. Let's say we have Steve, then we have Bill, and then we have, let's say, Yash. Now if I run this, there you go. We have a message printed, hello, Steve, Bill, Yash. Okay. Now coming to the final section of our demo, here we are going to find out the area of a circle and a sphere. So we are going to define 2 functions, one for circle and another for sphere. So first of all, let me define the value of pi, which is 3.14. I'll start with def. I'll give my function name as circle area, and inside that I'll pass in my argument, that is radius. I'll give a colon, and we are going to return the area of a circle, which is pi r square. So I'll have radius, again an asterisk symbol, and then radius. So this becomes pi into radius, which is pi r square. Okay, now let's define another function called def. I'll say sphere area. I'll have my argument as radius, give a colon, and say return 4 pi r square, which is the area of a sphere. So I'll have 4 multiplied by pi multiplied by radius multiplied by radius. So this becomes 4 pi r square. Now we are going to define the main function. So I'll say define main, where we'll just have our print statement. So I'll say print circle area with radius 15. I'll give a comma and say circle area, which is my function name, and we'll pass in the value of the radius, which is 15. I'll just copy this message and we'll print it here. I'll say sphere area with radius 15 is, I'll just change this to sphere, and let's say we'll have radius for 10 instead of 15. Okay, finally I'm going to call my main function. So I'll just say main. Now let's run it. Okay, there is one error here. This is an indentation problem. Now we'll run it again. There you go. So the circle area with radius 15 is 3.14, which is the pi value multiplied by radius into radius, that is 15 into 15. So the value is 706.5. And similarly, the sphere area with radius 10 is 4 into 3.14 into 10 into 10, that is 1256. Alright.